So if you remember in our last episode, we were talking about the data lifecycle, the human aspects of data lifecycle. And I want to remind you at this point, this is a class about humans and AI. So we're not going into all the details. We're not going to teach you how to do data analysis, any of that stuff. But I want to tell you all the parts of data collection, management, use, all that involve humans. So what we're going to talk about today is knowing, you have to know a certain amount of the basics, right? There are different kinds of data storage types. We have data warehouses that we can use. Peter was part of the team that put together this book, which I highly recommend to you, which basically gives you the human story, how people actually collect, use, organize, manage data, especially in the context of AI. So we have these different kind of data repositories, warehouses, data lakes, and so on. People have they stopped using data silos because, as the name implies, it's hard to use and difficult. So now, one of the things you need to know, the human part of all this data collections that you've got, are how do you, the human, understand what that data collection is all about? And so in the past couple of years, the world has started turning to data cards. Every time you get a data set, there should be a data card, which is the sort of meta description of the whole pile of data you've got. In the previous iteration of this class, we had an assignment where we gave you a data set, which was the US Census and a whole bunch of different properties of people in the data set. And almost everybody got that problem wrong because they didn't read the data card. The problem with that particular data set problem we handed out was that the data card said very clearly, this is a subsample of the entire population. And people did not read that line. And you need to take on as personal practice, read the damn data card so you understand what data set you're working with, its properties, its biases, all that sort of stuff. So a data card comes along with the data set. If you get a data set without a data card, be suspicious. Be suspicious, because a responsible data provider would give you a data card. Now, in the same way, AI models come with model cards. A model card is very much like a data card in that it describes the model, how it was built, who built it, what the conditions are, the range of applicability, all that sort of stuff. So there in this slide is a link to the Gemini 2.5 model card. So among other things, a model card describes when the model was built, its knowledge cutoff date, all that kind of stuff. So when you build with a model, just as you did with building with data sets, you need to read the model card to understand the properties of that model. So as you can see here, it's it's actually a fairly long document, but it has a section for ethics and safety, use and limitations, how it was evaluated, what the evaluation results were, all that kind of stuff. Okay. So data cards, model cards. Now, when we build models, there's always a data pipeline. You may not think about it, but there's always a pipeline. There are lots of different pieces of the machine learning operations workflow. So we collect data, we ingest it, we transform it, we prepare it, we train the model. There's all these different steps. You can learn all the details of these steps in another class, but I want you to pay attention to a couple of things here. So how's the data prepared? How's it transformed? Because lots of interpretation, lots of human side analysis goes into those steps, okay? So we need to understand all those steps. In the middle of all of this, as we're collecting data, as we're transforming data, as we're labeling it, as we're creating the models, you always have to be aware of privacy and security. I know you don't want to think about it, but you gotta. Somebody has to be responsible for monitoring the privacy value of the data sets and how secure it's kept. So here's a fundamental problem. Everybody wants private data, right? But as you know, people are more than willing to give up private data for a cookie, a literal cookie, not a HTML cookie. Or they're willing to give it up in order to get a little bit of service from some kind of provider. So people say they want privacy, but they're more than willing to give it up. They also want to be able to delete their data. Part of privacy is saying, hey, service provider, you used my data. Now I want to delete it. And so what happens? People have contradictory requests. They will tell you, delete my data. And then the next day they say, well, no, I didn't mean that. Bring it back, right? So as a service provider, as an AI service provider, if you're building these things, be aware that people don't know what they mean when they say what they mean. So we need to encrypt it, but only I should have the key. Oh, I can't give you the key. Oh, I'm sorry. Right? So this is human behavior, right? So there's trade-offs all the way down, and there are human trade-offs as well. So over the past few years, there have been different kinds of releases of data. So one of them, the most famous ones, was a couple of years ago when Netflix put this recommendation contest. They put up a whole pile of Netflix data out into the web and said, here you go. If you can make an recommendation algorithm, which is X% better than the one we've got, we'll give you $100,000 or whatever it was, right? They did this. On the other hand, people found their data in the data set and they said, that's not private, that's not anonymized. Whoops. So, and this happened just a little bit before, actually the AOL did the same thing, where they released a whole pile of search log data. And they had very smart people going through and trying to anonymize it. So they removed IP addresses, they removed names, all that stuff, right? And an enterprising reporter at the New York Times was able to find out people's phone numbers and call them up and ask the question like, did you really search for Saving Private Ryan on November 21st? And they said, why, yes, how do you know that? Point is that clever people can reverse engineer even pretty anonymized data sets. And there's lots of interesting stories about that, which we could go into. But the takeaway for you is that it's almost impossible to really anonymize data sets, which is why Google doesn't really share data. They saw AOL get burned, they saw Netflix get burned, they've seen multiple instances where theoretically anonymized data was turned out to be revelatory. And the problem is almost always, you can prove that the AOL data set was anonymized. The problem is that there are external data sources that you can then join on a foreign key to get information from X, combine it with information from the data set Y, and get inside information. It's really tough to do. Be careful when you go down that path. What could possibly go wrong? Just told you. So we also want to provide data security against intruders. And here's Tom Cruise doing that thing he does. So we need to establish data access policies, right? You need at least multi-factor authentication. You need the principle of least access to the data. You need, as a responsible HCI AI person, to have a data loss prevention policy. So you need to be able to, I know this is sounding like software security. This is starting to sound like, the guys who sit in that back network room and do all the multi-factor stuff. It is. It's part of your job to be able to provide all this sort of thing. There's a model called the 3-tier database model, where you've got client server, app servers. That's proven to show the best isolation for your data sets. But you need to also be able to provide data discovery and provenance information. So you need to figure out what you've got, where it came from, that's provenance, where did your data come from, and how sensitive it is. And note that sensitivity varies by population. So for example, some people view their personal image as not involved and not sensitive at all. Other people don't want to have their digital image anywhere. So you need to be sensitive to that. So all of this involves physical, administrative, and technical controls. You need to do things like make sure you can lock people out of server rooms, that you don't give access to cables that's going between different instances. And you need to teach your people how all this works. So encryption, right? Obvious answer, let's just encrypt everything. You also need to think about encrypting in flight. So data on a server could be encrypted, it could be physically secure, but when it's shipped from data center 1 to data center 2, if it's not encrypted in flight, you've got an exposure. So again, for all the HCI reasons, you need to worry about all this stuff and not just external threats, but you will also have, in a sufficiently large company, internal threats as well, where there are people who have specifically joined your company in order to gain access to internal information and then exfiltrate it to get it out of the company and share it with someone else. So this is obvious, but people don't do it. Keep your system updated, apply the patches, and think about zero-day threats, right? So there's also a bunch of issues about serving content, keeping content in the cloud versus keeping it on-site hosting. Lots of places, I'm thinking Japan, I'm thinking Brazil, require on-site hosting. In extreme cases in Japan, you cannot store any data in the cloud, even in Japan. It has to be physically in the building. Again, that's a level of security and physical protection that they want. You need to think about how do you do that. What this is telling you, I hope you're taking away from this, data is an asset for you. It helps you to build your models, helps you to run your AI, but it's also an exposure. Data is a liability as much as it is an asset. Right? So I've told you some of the possible problems with storing data, keeping it, shipping around, all that. Now there's another layer here to think about. The ethics of data use, data collection, transformation, provenance tracking, and so on. So there's a lot of different aspects to this. This is true for AI systems. It's true for non-AI systems. So if you're Visa, MasterCard, you've got all these data ethic issues as well. You need to think about privacy and stewardship again. The accuracy, this is going to come back again in a little bit. Where the data is coming from, its provenance, its intended use, ownership's right, reliabilities. And the US actually tried a couple years ago to codify this in the US AI Bill of Rights. So during the Biden administration, there was a big to-do about making data safe. And so these are the provisions for that code. Unfortunately, I think this has now been kind of rolled back, so I don't know where this stands now. But this is, I think, a very reasonable first cut. People need to be protected from systems that are unsafe. So you need to know what systems are unsafe. We need to avoid discrimination. We need to figure out what abusive data practices are. And basically, the bottom line is people need to understand the data that's out there, how it's being used, and what they can do about it. What can they do? So we've got a lot of data equity best practices so that people get equal access to data and the transformation and the use of that data is equitable across different socioeconomic classes, ethnicities, regions, and so on. We want to be able to give marginalized communities equal opportunity, which is sometimes tricky, right? So if you want more details on this, Peter's put a link in here to the Belmont report, which talks about beneficence, respect, and justice as being three key principles for ethical handling of data. So we believe, I think Peter would agree with me, we want in our data handling, our ethical stance of data, to counter stereotypes and bias, and be careful and think about who's gathering the data and why, and be accountable to the public. Part of that being accountable is understanding how people think about the data versus how I think about the data, I, the technology person. So for example, is it okay to lump together Middle Eastern, North African, and Pacific Islanders all in one category? Is that reasonable or not? Probably not. You know, once upon a time when a bit cost you real money, you might group all those people together. Now, a bit or two is not going to cost you anything. So try to be more respectful of representing different kinds of differences. So data collection is interesting because You can build, for example, a search engine. So here's Google as of 2022 for the query brides. And you notice anything interesting about that? A lot of white people there, right? A lot of Caucasian brides, and there's one Indian bride down there in the bottom right. Now that was 2022, and about that time, Google was making a big effort to try to diversify search results and make it more representative of the US population, or the world population. So this is the US as of the following year. So after the debiasing effect went into place in the search algorithm, you get a lot more variety here, which I would argue is a better representation, better set of results. If you go forward to this year in Switzerland, so I ran this query today in Switzerland, you get very, very similar kind of results, even for Switzerland, even though the population is very different. The statistics are different there. And of course, if you do it in the US, you get a slight variation there. So this is Google being very conscious, very aware of the bias effects of their data sets and how they collect it and what shows up in searches. So that's, in some sense, a shorthand version of ethics for data provisioning. Make sure your results are representative. Make sure the data is equitable. Do your best to keep it secure, private, and all that. Now, where does data come from? Data comes from people. And data workers are the people who are actually on the ground typing, entering data, whatever it is. And our colleague at Google, Nithya, gave this really interesting paper pointing out that everybody in AI wants to do the model work. Building a model is the sexy stuff. Everybody wants to do that. They want to build a model which will infer something great. Fantastic. But data is the lifeblood of machine learning. Data is the foundation for all machine learning stuff. So where your data comes from, who creates it, how it's collected, how it's labeled is absolutely critical. And yet it's kind of undervalued. So it's about 25 to 60% of the total operating expense cost of machine learning projects. Okay, that's a big chunk. If you just look at it as a project manager, you say, well, I want to pay attention. Maybe I can get that 50%, 60% down. So we need to think about how humans collect this data. So in her study, Nithya basically did this study in India, looking at the data collector in the field for public health application, and then looked at the raters, which are interestingly in both India and the Philippines, and then where the researchers and developers are. They're in the US, India, Nigeria, they're everywhere, right? So she did all this nice work and basically discovered, dang, all kinds of possibilities for mistakes and errors and bias effects. So if you think about, okay, the next step you get all this data, let's assume it's labeled by humans and it's done well. Developers like Andrew and Eng here and colleagues get to work on it next. And so one of the things to realize from today is that there's a thing called the data cascade. So you start with a problem statement, you start writing a definition of what that thing is supposed to do, you collect and label the data, you analyze the data, you select the model, you train the model. This is that whole linear process. However, every step in that process affects every other step. So the way you state the problem at the very beginning will affect the kind of data that's collected. It will affect the labeling process. It will affect the way the model is deployed. So things can go wrong at every point along this process. So if, for example, you say, we need to collect data on health information from Central India in these months, right? That's great. Then you hand it off to some project manager who says, Central India in the monsoon season is a pain. How about we do it in winter? And so they don't bother to report back to the PM, we're going to do it in a different time of year. That will fundamentally change the data set. And everything is connected. So when you move one thing from point A to point B, all this stuff can have impacts. Then you go all the way down, you build your model, and then you deploy the model, and your fabulous tool is being used by people in the field. But they don't understand. They didn't get the model card. They didn't get the app card that describes the range of applicability. So we've seen problems with models being deployed in different ways. So there are all these interesting factors that come up in the data cascade. So we have these incentives that are baked into the process. So for example, an incentive might be label as much data as possible. You get paid on the thousands of data points you label every day. What could be wrong with that? Any suggestions? What could be wrong with incenting somebody to do as many items labeled per day? What do you think? Yeah. Right, right. So the reply, which I think is correct, is they are then incentivized to get as many clicks as possible. So they tend to click A, or whatever the first option is, right? That in the survey biz is called satisficing. People will satisfy all the time. And so the clever data analyst, person who's organizing and running this, will set up an internal check. You know how surveys often will have attention checks? Like the question is, click on the third button. And if somebody clicks the first button, you know they're not paying attention. Okay. Same thing for data collection and labeling. Rather than incenting people to do as many as possible, you incent them to do as high a quality as possible, and you've got a measure of that. And so what you would do is bake into the data collection questionnaires attention checks so that you know. So for example, you put in some questions and labels where you know the answer already. And if they choose something other than that, you know they're not paying attention and it's time to retire them. Not with prejudice. I'm just saying, you know, you're bored now, we're gonna move you off this project onto something else. You have to have that in your data collection and labeling process. So it's true that, you know, it's one of these things, it's tough to get data, especially in high stakes domains, thinking medicals kinds of things. We've got all these different kinds of things. So people tend to create data sets from scratch in that field, even though it's pretty inefficient. But a huge part of the problem is the data collection practices and standards and definitions that Tobias might have done last year is not at all what I need this year. So I'm gonna make mine from scratch, right? We also need to support things like geo differences. That is much more important than you might think. The way people answer, for example, medical questions in Britain is not the same as in the US, and it's definitely not the same as in Australia, even though those are 3 English-speaking countries. So you need to think about all of this and downstream accountability. What I mean by that is how your model, how your AI system is deployed in the real world. The quote here is, if you build this model for predicting eye disease, and it predicts that this person does not have it, you will leave this person to go blind. So a false negative is a disaster. So you need to think about what's the rate of false negatives or false positives if you're predicting something like pregnancy or COVID. Those both have terrible outcomes. So here's a picture of a place that's doing rating. So we've got all this data cascade. We go out and find the problem, we figure out what we need to collect. We then hand it over to raters, and raters sit in places like this, and they go through the data sets every day, and they kind of label it appropriately. So the raters are doing all of this, but just because this is a rater situation, say in the Philippines or in Nigeria or somewhere, you still have to think about the HCI aspects of this, because we've seen raters be given applications that, for example, have no undo. What? How can you do that? That's HCI 101. And yet a rater is expected to be perfect and never have to undo anything. So you need to pay attention for that kind of thing. You need to allow people, including raters, to do undos. You also need to do things like inter-rater reliability measures. So it's not just, you know, you deploy this thing and then let it go. Aim your design for the rater application to be human first or rater first. So it's like that, but you are responsible, even if you're located in Mountain View, You are responsible for making sure that the raters who are creating your data have a good experience. Now, let's go back one step further in the data cascade. The raters are rating data that's collected by the collectors, right? Right? So here we are in India, taking temperatures of different people. So the frontline workers, that is the people who have the instrument, the people asking the questions, they collect the data, and in the medical case, it's often healthcare, community healthcare workers. Great job for them, okay? Again, you can have misaligned incentives and poor data literacy. So what we need to think about is how can things go wrong there as well? I know. I'm always talking about the way things can fail. But in this case, you, as the person doing the AI work, need to understand the ways in which data collection can fail. The example here from Nithya's study is that often they forgot, the data collectors, to reset their GPS app instead of recording it every 5 minutes and recording every hour. Totally screws up the location data. They weren't told that. That meant that entire years worth of data had to be trashed. Okay? You can make a mistake early on in the data cascade and invalidate your entire data. So, summarize here. We've got all these steps that we need to take to make sure we have great data at the end. Great data so we can build our model and build our AI tool. What I'm trying to give you a sense of is all the different places where HCI has to be involved, right from the initial collection of data through the data ethics and practices and privacy, security, through analysis, through labeling and all that. Okay, HCI is part of this. Even though people try not to think about it, they just want, I'm going to give this to a junior PM and let them handle it. We have to be involved at every step in the process. But I'm going to now pop back to what Peter would have been saying if he were here today. With AI news you can use, I have a couple of things. First, I've got one thing that's a piece of work that was done here at Stanford. So there's a system now called Paper to Agent. It's on GitHub. You can find it, try it out yourself. It basically converts technical CS papers into an AI agent. And this is not quite the way I think of an agent, but it's kind of fun. They basically then create this interactable thing, much like a Notebook LM does. So you take the paper, it then processes it, creates this kind of nice representation with interaction and visuals and all that stuff. Very nice piece of work. And that's the workflow they've got there. Ultimately, they create this thing called the paper agent, which to them is an interactive version of the paper. Cool. That's thing one. Thing two, Logitech CEO Hanneke Faber said she would consider adding an AI agent to her board of directors. I have no idea what to say about that. Either a bold move or just silly, because I suspect that AI agents will just become part of the background. It's equivalent. I think it's a little bit like saying, I'm going to add a spreadsheet to my board of directors. You could, but that would seem foolish. So what she's trying to get to, I think, is to have a participant on the board which knows everything and can be asked questions at any time. The reason you have a board of directors is to have diverse and deep expertise. So a board of directors, say for Logitech, might have a director who knows physical hardware systems very in deep detail. That's, I think, what she means. We want another participant on the board who has deep knowledge and is trained up on all of the stuff that's going on. Okay. Yes. Uh-huh. Right. Mm-hmm. Mm-hmm. Mm-hmm.
Then this is not the first person I've heard of who wants to put AI on their board.
Right.
Third is everyone is looking for AI specialists for their board.
Right. Right. We're going to talk a little bit about some of that, but that's an interesting point of view. Thank you. Thank you for that. So my perspective is AI agents should be available to all the board members, right? It should just be a tool. and that I imagine that 5 years, 10 years out, I can't imagine being on a board without having an agent available to me to use. So for example, our trusted course agents over here have been building a notebook for every class. That's a way to have an agent for this class. So speaking of fun stuff, assignment 2, we've now got everybody's is turned in, which is great. Now, reminder, this is what remember, you've done it, right? You know what the assignment was. It was to generate a party invitation in the style of the Gilded Age, and there's some data about what should be on the invitation. Cool. So Gilded Age refers to the 1780s to about 1900. Comes from Mark Twain's book called The Gilded Age, a story of today, a tale of today. So that's where the term comes from. But I hope you all did this. I hope you all did the obvious search for Gilded Age party invitations. And I hope you saw things like this. And I'm going to show you a few more. And I hope what you're internalizing from these examples is what these things look like. And thus what your output should have been, right? Now, this is a nice one. It's got this beautiful image on the left. And the handout, the thing you bring with you on the bottom, right? And so what I did to solve this problem is, and there's another example. What I did was looked at all these things and said, what is the characteristic of the image I'm trying to make? One of the fundamental problems with Gen AI systems, as I'm sure you discovered, is that you have to actually tell it what to do. So you should be using language like this. I need a mixture of sans serif and serif fonts with highly decorative or display fonts, multiple layers with clashing typefaces, ornate fonts, often with a handwritten name, et cetera, right? So these are all things that I noticed just looking at those. So that's what I would put in my prompt, right? As opposed to saying, for example, create an invitation that looks like it came from the Gilded Age. See the difference? I'm being specific. You might accuse me of being hyper-specific. Yes, I'm being hyper-specific. So I'm showing a couple samples from you, because I want to I'm not going to give any names. These are all great examples. But notice anything odd with that? A lot of the invitations I've noticed have these interesting little characteristics. So there's the typography is not typography done by a human. There's also a couple of misspellings in it. The corner of Royal, North Royal and Cameron. Interesting. Here's another one. These are all lovely, like I said. But again, Alexandria, Virginia is not a place. All right. Here's one where the spelling gets even worse. All right. So again, I'm not going to tell you who these are, but and you don't get points off for generating this. As part of the assignment was to figure this out and to notice this stuff, right? You will lose a point though if you turn this in and don't say, hey, man, the spelling is terrible, right? Part of your job as a designer is to know the limits of your tools. These are AI tools doing generation of images. You need to know that that's kind of wonky. Or here's another one where typography looks close, but it's not quite right. Alexandria, Virginia, also is not a place. It's just sort of interesting things like that. Now, I want to tell you three things. The first one was I already made. Be specific. Figure out what you need to tell it in order to get the correct kind of image generated. Okay. So, second thing, we're going to talk about style transfer as an HCI AI concept in a couple of weeks, but I'm going to give you a preview today. Here's an invitation, a party invitation I found on the web. And what you can do with these Gen AI systems is to say, hey, use this image as a guide, create a party invitation to Spring, again, all the details, Springfest to be held at 5B Sternenstrasse. Include the text, please bring your own beer. Using as a guide is the key phrase here. because this is what it generated. Ta-da! Right? It copied the look and feel. It copied the font. It copied the color. It copied the botanical illustrations, and it got it right. Let's go take that a little bit farther. I handed it a cosmetics website and said, using this website as a reference, create a homepage for a modern bakery. A little bit more detail right there. And it generated this. Okay. You see where I'm headed? So you can take this style transfer as a basic idea. So here I'm using Gemini. I took that really beautiful invitation I showed you earlier, and I said, please create an image following this ticket image as a style guideline, blah, 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 blah. And here it is. Very nice. There's some spelling issues in there, but it's not bad. The appearance of it is quite nice. But the assignment said portrait mode, not landscape mode. That is a vertical aspect ratio, like this, not like that. Right? So I say, hey, that's not landscape, that's landscape. Please make it vertical design. I will spare you the next 10 attempts to make this portrait. I never could get Gemini to give me a portrait image. Completely failed at this. Big lesson number 3. When one tool doesn't work, switch to another one. So I switched to Microsoft Copilot, gave it the same thing, same kind of this thing, and I said, comes out, I will point out, this is not quite as aesthetically beautiful as the Gemini image, but when I said make it portrait mode, it did it. I don't know why Gemini hates portrait mode, but it does. Right? The deep point here is you need to know what your tools can do, what they can't do. You need to check them and be willing to switch tools if you can't get the one you're using to do it. This is going to be true for AI tools going forward. There are very few things that are going to survive for 10 years that will survive for 10 years. Okay. I want to show you. Okay, so that's assignment 2. Let's start talking about agents. I'm going to show you 2 examples of work that's been done on agents in the past. How many people have seen the Knowledge Navigator video? Have you? Peter, no, one person raised his hand. The rest of you honestly haven't seen it? Okay. And this is 1987, Apple. And there's a long story I could tell you about it, but I'll tell you the short version. The short version is they had a vision for where Apple was going to go in the future. And it was explicitly an intelligent agent support system. So I'm going to run, I won't show you the whole thing. You can go watch it whole thing. But let me jump around through it a little bit. I'm sorry about this. This is pre-digital sound. This is my life. Conversational UI. I can do this now. I'm going to skip forward a little bit. So it shows graphs from the selected images, the selected papers. And eventually, oh, she calls back. She ends up giving a lecture. So the really interesting thing about this for me was, I was alive in 1987, and I remember watching this and thinking, oh, the future, right? This is a vision. It really was a visionary piece. And then when I joined Apple about 8 years later, one of the jobs we were given was make that real. And we did a fairly decent job, but never quite got it all. Everything in this video can now be done. So remember the example Peter gave about that XKCD cartoon was how long would it take you to do this? We're here. We're now at the point where we can actually do this. Another thing that happened about 10 years later was that Microsoft shipped an intelligent agent called Clippy. How many people have seen the Clippy video or know about it? Okay, a couple more people. So let's say 5 people know about Clippy. I'm going to show you just a little clip of the Clippy video. Which was their previous attempt at doing that. The interesting thing about Clippy was, as he points out, it was imprecise. It would try to intervene and give you advice about things you already know how to do. And so Clippy died a death just a couple years later. It just vanished out of the office environment. Building an intelligent agent that interrupts you and gives you sage advice at the moment you need it is really, really, really hard. It's one thing to have a conversation with, say, Siri, where you invoke it. You say, hey, Google, hey, Siri, whatever, right? And you go back and forth. It's another thing to have the intelligent agent interrupt you with appropriate things. I was involved in a study at Google a few years ago where we did a Wizard of Oz study, just like you're doing now. We did as a Wizard of Oz study where we tried to build an intervention agent that would listen to a conversation going on in a conference room between, say, 2 or 3 people, track what's going on, and as you know, speech recognition is pretty good, so we knew what was being said. We even had speaker identification. We knew who was saying what. But being in the other room as the wizard and trying to decide when to put up a graph or a piece of data or when to intervene, when to interrupt, was tremendously hard. We found that we couldn't do it gracefully. Humans have a hard time. So it's a tricky problem. I think it can be solved, but that's another piece of research. So doing Clippy with this interventionist style was tremendously hard. Okay, now let's get to the meat of the day. What is an agent? Basically, it's a piece of AI software that pursues goals and tries to accomplish tasks on the behalf of the user. So ChatGPT, Claude, basically involve you in conversation. They're not an agent. That is, they can't reach out into other programs and do stuff for you. Now, I'm going to modify that a little bit, but basically, when we talk about agents now, what we're talking about is code that can run other pieces of code. Okay, So there's a thing called the MCP, the Model Context Protocol, and not the MCP from Tron. Same idea. It takes over and actually connects different agents using a standardized protocol. They can do a little bit of reasoning, they can do some planning, and they have autonomy to do stuff for you. Now, like I said, this is not a new concept. The idea of intelligent agent has been around forever, right? So it's an agent, it's a piece of code that perceives information, takes action to accomplish a specific goal. So here are some examples of that. I might say to my agent, order me a new ice cream scoop on Amazon. It would then figure out what ice cream scoop is, what my expected price range is, go to Amazon, order it, ship it, so on, right? It could do something like buy me a new domain name and configure its settings. Now, what would a human do in this case? If I say to you, buy me a new domain name, what's the first thing you're going to say? What's the new domain name, right? So it has to have some conversation, or it has to have an extremely good model of me. So it might want to buy the domain name danrussell.com. Then looks it up and says, oh, that's $20,000, forget it, right? Or book a Valentine's Day date for me and my wife. Oh, I better have a pretty good model of me, better have a pretty good model of my wife, right? Because it's going to start calling restaurants or something, right? Something like schedule a haircut. Remember the duplex demo we saw? That was scheduling a haircut. Getting me an appointment with my manager's manager, my stipple manager. You can imagine how all this works, right? Okay. These are the kinds of things. Create a new marketing campaign for new AI-powered shoes. Ordering a new ice cream scoop, pretty straightforward. I know how to implement that. Number 6, create a new marketing campaign for my AI-powered super shoes. That's a Nike agent, or it's a marketing firm's agent. How would you build that? You might want it to invent the logo and color scheme, the font, write the social media posts, schedule them to run for best effect, post them to these platforms, all that stuff, right? How does it know what to do? Well, that's what LLMs are for, right? That's what AI is all about. So an agent will decompose your task into some pieces and then start to figure out how to run them all or allocate them to sub-agents, right? This is an important idea. So give you some examples here. Agents can be many things, but as I've said in previous lectures, having a mental model for what your AI thing is really important. So what are the mental models people have of AI agents? One is a digital assistant, kind of like Siri, right? You say something, it does the right thing, responding to what you do. It may pop up an announcement saying, remember, you need to practice for your history test tomorrow. Okay. There's another category of intelligent agents called B2B assistants. So these are primarily business-to-business communications. So they're not stuff that you probably have dealt with a lot. But there are companies out there that basically do nothing but connect business to business in response to goals given to it by somebody in the company. So arrange for this kind of shipment of this kind of material to this kind of place, all B2B communication. There's the mental model of an AI agent as a team member. And now we're getting good enough to synthesize synthetic people like this and animate them and have a conversational UI. Preface, we're going to talk about conversational UI in detail in a couple of weeks. But these kinds of mental models of an AI as a team member are out there. And then there's the companion mental model. So these are 4 current different kinds of mental frames that people have when they think about their agents. Assistants, team members, companions, right? So I'm going to show you a couple more demos because these encapsulate sort of the latest work. And this one is from I'm jumping in the middle of this. So it created a plan, and it's getting authorization to run the plan. The plan means we are buying like. So open an Instacart, open a browser, go into Instacart. You get the idea. So this is the agent opening a web browser, going to a website, starting to interact with the website. So it's taking action on your behalf. Now, as a computer scientist, you might say, that's just an API call. This is an API call. This is actually interacting with the UI. It's actually putting the cursor into the input buffer, typing, et cetera, et cetera. Right. So here's another example. This one's from Google. It's called Project Mariner. The agent is now doing this, not the human. Again, the agent is running the browser. Okay, a couple things to point out. First off, it takes action on your behalf. Second, it remembers stuff so you can cache it for future use. And not just the thing that it's doing at the moment, but the abstraction of the action. Okay, so these are pretty interesting kinds of agents. So what an agent can do is to do a little bit of reasoning. Some reasoning over the task, reasoning over the pieces of the task that you're doing. It can take action in the world. It can observe and watch as the browser comes up, or as the UI for whatever tool you're using comes up. It may have its own optical character recognition, natural language, speech reco, and so on. It has to plan, because if you're going to do something, it may involve multiple steps. You have to create a sequence. May have to collaborate with other agents, and it can get better over time. So this is kind of the next step of AI tools, is the agent that could do all of that. So what we've done, we've seen agents in various forms be around for a long time. Mostly they've been pretty hard-coded. So when I said I was working at Apple to rebuild the Knowledge Navigator agent, what we were doing was basically building a very carefully constructed, beautiful, crystalline piece of code that would break if anything went wrong. There's a lot about it. But what we're trying to do with the new age of agents is to use large language models to help unpack a lot of this stuff, like the reasoning, the coding, the observing, and all of that. So here's an example, a data analysis agent. This was made in 2016. And you can ask a question of this agent, a question like, what were my sales for this project in Northeast region in Q2? And then this data analysis agent would break it down into these 5 steps to do X, Y, and Z, right? Do all of that. And it worked, a little brittle, but now, of course, with AI, as seen in things like ChatGPT, Claude, Gemini, so on, you can do it, the estimate was half the time, improved accuracy, by handling this as an agent operation rather than trying to build the code explicitly. And if you're interested, I'm not going to go into this today, there's a really nice sort of tutorial on how to build such an agent. Okay? So I'm going to show you a different part of that Project Mariner demo. And I want you to be thinking as you watch this, how am I, the human, working with this thing? how is it doing stuff in a way that I can understand it? Yeah, we've already seen that. We've seen that. My first thought on watching this was, I can't keep up. Okay. I can't keep up with what's going on with this single threaded agent. Imagine an agent thing can spawn sub-agents. So rather than doing all these companies in serial mode, it actually spawned one agent per company. So now you've spun out 100 agents, each doing this process, right? It's awesome for you as a human because it only takes a minute to do 100 agents, 100 lookups. However, me as a poor human can't handle 100 results in 30 seconds. How do you interact? How do you monitor? How do you track what your agent or agents are doing? So this is both the curse and the promise of agents. You can get stuff done at superhuman speed. The problem is you can get stuff done at superhuman speed. And if it's not the right stuff, you're in a heap of trouble, right? Not that anything could ever go wrong, right? So how do we help? What are the UI mechanisms to help people track and understand and maybe steer the flock of agents that are working for him? So here are some issues that are going to come up, some UX issues for agents. So agent trajectory, that is the sequence of things it does, is a vector of trust. Trust, let me say that multiple times. Trust, 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 trust. You need to trust your agent. And you as a designer and you as a system builder need to figure out how you can help support and engender trust in the part of the user. So being able to see what the trajectory is important. Part of that is the trajectory shows how the problem gets solved. So you want something, a reasoning method, a protocol that I can understand. I do not want a step in that trajectory to say, a miracle happens. I don't want that. So we need to be able to see how these things are solved. And guess what? As I said the other week, anytime you introduce a new technology, you introduce new security problems, new security challenges. Suppose you've just spawned an AI agent which sub-spawned 100 sub-agents. How secure are all the sub-agents? Do they all follow the correct security protocols? Or did somebody cut a corner somewhere? If you're going to build these things in an enterprise setting, you need to be able to adopt not just reasonable assumptions of behavior, but also enforceable and trackable business protocols, business rules. So it's one thing to write a prompt to say, hey, AI, I want you to do this for me. It's also one thing to build in a set of guidelines so the AI will do the right thing. But the guidelines need to be the same as or equivalent to the business rules of engagement. So what you might do or your agent might do as an individual may or may not be what your business would allow. Think about, for example, you're creating a website, you find an image out on the web, you copy and paste it, that's fine. Nobody really cares about your one-off thing. But if you put that on a website that gets 1 billion views a day, all of a sudden the copyright police go crazy. So the business rules may not be the same as individual rules. You need to be able to understand that your agent has implemented this business's rules. So you probably noticed that most of the AI systems these days have what's called a deep research mode. And it's a kind of agent because it will go off and do a bunch of additional work on your behalf that you didn't specify. So deep research actually has a planning phase. You've probably noticed, give me deep research on topic XYZ in the 16th century, right? So it will then create a plan, show it to you, and I always say yes. I don't know about you. I suspect you always say yes as well. You say, yes, go for it. And it will then go through that series of steps, check that set of websites, that set of sources, and then integrate information for you. So I did that here. I said, write a suitable analysis about the development of Zurich as a city. And I created this thing. So here's the plan. And it's basically saying it's going to go check these research websites. It's going to analyze the results and create the report. Fine. So it checked 134 websites. So this is deep research intelligent agent. So it checked 134 websites. And it wrote me the report. And you might be forgiven for saying, oh, yes, we have intelligent agents. We're done. We now live in the era of deep research. Right. But, you know, if you actually look at it carefully, there's a bunch of events in here, because I read this carefully, because I'm pathological that way. And so I discovered that a lot of the events were actually out of order. And the data on the rat house is correct, but the work it cites has no information on the rat house, so it's hallucinating. You know, this is a problem, right? So we've got these different categories of things. We've got intelligent agents, intelligent assistants, and bots. So in some sense, here's a distinction. A bot is an old-fashioned agent, right? They automate simple tasks. They have predefined rules of capabilities. They have basically only reactions, no triggers, right? An assistant like, say, Siri or Google Voice, it will assist you with specific tasks, but you have to invoke it. An agent can autonomously, proactively perform tasks. It will do stuff for you even when you haven't asked for it. It can do these complex multi-step things and they get better over time. So this is, you're seeing the evolution of AI tools. So let's talk about how you build an agent and the important pieces of it here. So every agent has a role, responsibility, personality, particular way that interacts with you. So there's you. There's a mental model. There's a persona that the agent adopts or you impute to it, right? An agent has memory, that is the things that it knows and remembers about what you've done. It also has access to all these tools. That's what makes it an agent. It can reach out and grab a browser, it can reach out and grab a spreadsheet, it can reach out and grab your calendar, right? All those tools. In between you and all that is a model that's created. It's usually a large language model, decorated, annotated with all kinds of additional things to make it happen. So what we do, now we finally gotten to the UX of interacting with an intelligent agent. You establish a goal. Okay, agent, I want you to cure cancer, or whatever your goal is, right? You might go back and forth and have a conversation to clarify and what defines success. And so there's then execution tools to help you monitor what's going on. And a big question that is still unanswered: how do you intervene? You've just spawned 1,000 subagents, and one of them is going cattywampus. What do you do? Hey, you have to notice it. What do you do? How? Okay. Okay. Hold on to that thought. Control C doesn't, I mean, you've now got 1,000 different possible things that you can set a Control C to, right? To stop it. But it's exactly the right kind of thought. We need to understand what our agents are doing. So there's one approach. I mentioned looking at agent trajectories, and I'll show you just a little bit of this. This is a way to run through this. Basically, this is a tool for looking at and depicting the different steps the agent goes through. And so this is out there. You can watch the whole video on your own time. I want to point out a couple things. The interaction between different components is through JSON blobs. So what it's doing is one piece of the agent will do blah, 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 blah. Oh, create a JSON, hand it over to the next part, right? So it's not using any fancy API mechanism. It's using essentially what is essentially funky natural language, right? So what you can do with this, though, is then to watch as an agent does stuff. You can see its trajectory across the space of possible actions and say, that's not right. I would never do that. So interesting problem. So this is, oh, I thought I had a video here. Maybe not. Shoot. I will tell you the video. You can go watch the video on the link there is to the video. This is Cassie at used to be at Google, and she's using an agent, the operator agent we saw earlier from OpenAI, and she's testing it out. And she says basically, I want you to find a romantic evening for me and my sweetie in New York City. And it goes ahead and does it. It's really fast, and it sets it up for the wrong date. She doesn't know that until after the hotel has been booked and the restaurant has been reserved. See the problem? It's happening like this, and you don't know it until the credit card bill says, oh yeah, you're gonna go have a romantic Valentine's Day on February 4th, not the 14th, right? So this is a problem. It's gonna be an issue for research going forward. So let's spend the next 4 minutes talking to your neighbors about this question. Remember the problem about creating a new marketing campaign for AI-powered shoes? What could go wrong? You have 4 minutes, go. What could happen? All right, all right. What have you discovered? What have you learned? Anything? My little group had a great point. You said something about social cues. Can you repeat that? Right. Correct. Very good. Okay, so missed social cues and reuse in different markets for potentially different cultures, different languages. Anybody else? This is your chance to be famous. This is all going on the recording. Then, first.
Like when it comes to like making a logo or scheme,
Yep.
does anybody have like a checklist say like similar to another company? Is this like
Ah, good point.
So it's like especially if it's the schedule up and if like the
Right.
schedule is like out or check it,
Yeah.
then it's already out there. You can trust
Yeah.
art or like get that like people back or copying
Right. So this is great. Potential failures in logo design for things that you and I would consider obvious. Like you would not make a logo with a swastika in it, right? How does the AI know that? Right? What do you have? Yes. Yeah. So is the platform choice a good one for the intended objective? Great. Okay. Nice. Thank you. So these are the list I came up with. So I'm going to leave you with a couple of thoughts and we'll get to the last question for today. I've said this a couple of times already, but you got to trust your agent. So how do you do that? How do you engender trust? How do you develop trust? Trust is built up with repeated uses and successes over time. It's easy to screw it up, right? This is true of humans. It's true of AI agents as well. It can also be damaged because of collateral incidents. There's not so much a problem with humans, but suppose, I'm going to pick on Google, suppose Google sets up an AI agent thing, which is fantastic, working really, really well, but then Gmail has a massive security breach. That's going to potentially damage the agent trustability. Right? How can I trust it when you can't keep Gmail working? Right? So one of the things I want to suggest is that building in transparency, like trajectory following, is one of those key elements of building trust for your agents. You need to be able to make it transparent. We will talk about explainability in the future. I know I'm doing lots of foreshadowing, but it's the problem with this field. Explainability turns out to be key. And we mentioned security earlier. Security by design is a part of having an agent that you can trust. It needs to be built in from the start. Let me close with this slide. This is a control panel from a game, a multi-person real-time strategy game. And the cool thing about real-time strategy games is you play them like there's a million of Warhammer, Civilization, you name it, there's a million of them. The cool thing about these games is that they allow you as the person in control to deploy your armies, your platoons, your individual soldiers or whatever, to build civilizations, to win wars, to fight battles, to figure out what the thing is. And in these games, you have control panels that allow you to see the disposition of your troops and what's going on. When you, as an individual, or you as a person in a business, have a few thousand of these agents off running around, we are, I predict, going to have UIs that look very much like real-time strategy games with giant dashboards and ability to intervene and monitor what's going on. So I think that's going to be the future of this. So if you are looking for a research project for your final project, this could be interesting. Just saying. So I suspect that that's going to be the future of these guys. Not that we're going to play Warhammer, but you know, it's going to look a lot like that. So here's my summary for today. We talked about what an agent is, how do people guide these things, what you have to do to modify it and monitor it. Do we need, for example, garbage collection of old agents? Imagine a world where I have launched 10,000 agents and then I die. Do they persist? Or are we going to be spending megawatts of power to keep old agent running for dead people? That's a possibility. So I want you to be thinking about this as we go forward into the agent world. And I'll give you this final question for today. People keep saying, I remember last year, I listened to all these podcasts about how 2025 was going to be the year of the agent. People are saying that about 2026. I'm just saying. Predictions about the future are really hard. But eventually, agents will be here. All right, everybody got it? Good enough. Okay, thank you, everyone. See you next week. See you, Peter.